3, 2, 1.
Here we go!
All right. Well, good morning, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. It is the last day of March, but as per usual, we always have lots going on. We have a triple header of live events coming your way. 2 exciting events with the Department of Fisheries and Oceans, and then we'll wrap up with an event at 1 o'clock Eastern with the Canadian Space Agency. So, as per usual, lots going on. If you've checked your inboxes recently, you know there's a brand new email with a ton of April events coming your way. You can choose to tune in live, catch the recordings, head over to the website exploringbytheseat.com, and you can find a whole bunch of our early April events ready for you. But let's get into that action with our final day here in March. We have an event with the Department of Fisheries and Oceans, who we have been working with for several years to highlight stories from their scientists, their researchers, and their science communicators. And today we're going to talk about something I know is in a lot of your curriculums, and that is invasive species. So we're going to have Rozon join us today, an aquatic science technician with Fisheries and Oceans Canada. So a big part of her job is to look at the big ships traveling internationally and how they can bring invasive species to Canada. Sometimes they're in places like the ballast water. Sometimes they're stuck on the ship's hull. So she's been traveling Canada's coast, collecting samples from all kinds of commercial ships, looking at answers to technology, to what we can do about this issue. So I'm going to grab Robin from backstage right now. Here she comes. Hey, Robin, how are you?
Good, thank you.
Great. Well, Robin, it's so great to have you live joining us today. I'm just outside the Toronto area. Where are you joining us from today?
Also just outside the Toronto area. We're here in Burlington, Ontario.
Okay, very cool. Well, I know from experience going over that big skyway that there's a lot of those big tankers coming into the harbor in the Hamilton area. So I imagine you can do some research right on your doorstep.
And we do. We often are able to get some ships here in the Hamilton Harbor. And we're actually located just underneath that big skyway bridge that you're talking about. But for the work that we did, and I'm going to talk about today, we needed some marine species and also some freshwater. But to get marine species, we had to go out to the coasts.
All right. Well, I want to start with a shout out as well to our classrooms who are tuning in. Don't be shy. Use the YouTube chat sidebar. Let us know where you're tuning in from. Send us some questions. We'll probably play a little round of Kahoot later as well. But for now, Robin, let's let you take over for a bit.
Okay, so I'll share my screen then.
Perfect. We had a nice tech check before we went live. So unless something sneaks up on us, I think we'll be good to go. All right. I see it loading. That's always a good sign. And there we go. Looks great, Robin.
Okay. Shall I take it away?
Yeah, absolutely.
Okay. All right. Thanks. So today I'm going to be talking about ocean hitchhikers, which is kind of a cute way of talking about biofouling on ships. So just a little bit about myself. I am an aquatic science technician with Fisheries and Oceans Canada, located in Burlington, Ontario. I speak English, French, and I'm learning Portuguese. My favorite food is cheese pizza, and I have a pet cat named Charlie. And you can't talk about your pet cat without a photo. There's Charlie. I do research on commercial ships coming into Canada. We work on all kinds of ships like tankers, container ships, bulk carriers, cargo ships, and ro-ros. Ro-ros are just a fun way of saying that they are car carriers and the cars roll on and they roll off. So specifically, I do research on the biofouling that is on the outsides and the bottoms of ships. Ooh. There we go. So what is hull fouling? Hull fouling is over time when plants and animals start sticking to the bottom of the ship. So when ships travel through the ocean or they stay still in ports, tiny sea creatures like barnacles, algae, plants, they can start sticking to the bottom of the ship and they make it slimy and dirty. And this process is called hull fouling, and we also call it biofouling. Think of it like when you get gum stuck on the bottom of your shoe. It makes walking harder, it makes you walk a little bit slower, and you can like spread sticky gum bits all over the ground where you're walking. And it takes time to scrape all that gum off and get your shoe all clean again. But it's like that, but for ships. So why does hull fouling matter? Well, it's bad for the ships. It makes them move slower in the water when they're covered with fouling, which means they need more fuel and it takes longer for them to get to where they're going. And that costs the shipping companies money. And it's also bad for the environment because those plants and animals that are stuck on the bottoms of ships as they come in, they get a ride to a new home where they don't belong. And these can cause problems for the local species that already live there. We call these new arrivals introduced species. So what's an introduced species? So an introduced species are living things that are deliberately or accidentally brought into a new area. They can be plants, animals, or microbes. They can offer human benefits like food and enjoyment, like lots of people like eating oysters. They might have impacts to the ecosystem, disrupt the food chain, and change habitat for other local species. And they might carry diseases that impact local species. They're also called non-indigenous, non-native, exotic, or alien species. Once these introduced species start growing and spreading, they're called an invasive species. And invasive species are almost impossible to remove once they get established. So I'm going to highlight a few here. So you might recognize zebra mussels from shells on the beach. If you've ever caught your foot on a zebra mussel, I know I have. They are definitely not supposed to be here. They are believed to have arrived to the Great Lakes through ballast water from ships. If your local pond has suddenly been covered in a leafy green, it might be water chestnut. Water chestnut was brought into Canada as a pond species that got loose. And if you're out fishing, you might see evidence of sea lamprey bites on the fish that you're catching. And sea lamprey are believed to have arrived through the main shipping canals in the Great Lakes. So let's ask some research questions, like how fouled are the ships that are arriving to Canada? And what parts of the ships are more fouled? And how much of this fouling are they bringing with them? What parts of the world are these species coming from? Did you know there's over 100,000 ships in the world fleet? So if you stretch them one after another, they would stretch all the way across the ocean like a big parade. And that most ports, because of all these ships, are connected in less than 3 voyages. Another question we're asking ourselves is, are there any potentially invasive species being brought in on these fouled ships? And what can ships do about this? Could they be cleaning more often? What kind of special paints could help? Other kinds of electronic protection systems might work too. So these are questions that we ask ourselves. So let me take you on what a day in the life of a person who does hull fouling research look like. So here's some pictures of me in the field. So on this picture here, that's me out in the field. And then here's me picking some samples out in the field and looking for critters. And then this is me back in the lab counting those samples. Okay. So step 1, we have to plan and pack everything that we need because we're shipping it out to the coasts. So we need to make sure we have everything we need ready to go and with us. The next step is that we email the ship's captain and we ask if they want to participate in our research. Then we go and visit their ship and we explain our project and we get permission to get started. It's really hard to see in these pictures, but these ships are really big. They can be 400 meters long, 60 meters wide and 50 meters from the bottom of the keel to the top of the containers. Now, for people local to the Toronto area, that's almost as tall as the CN Tower. So for scale, these things can be very big. So we work with divers that go under the water and they dive down, they swim along the side of the ship, and they collect samples for us. And I think because of their equipment and stuff, they sound like Darth Vader. They go like that when they're breathing all the time. We also use some really cool technology called an ROV, which stands for remotely operated vehicle. It's like an underwater drone that we drive around with a controller. I wanted to share this cool video that's the drone's perspective watching the diver in the bow thruster of a ship. So here you can see the bow thruster. It's just a big tunnel that runs through the front of the ship to help push the front of the ship into the dock when they're parking. And you can see the diver here. He's got lots of equipment that he has to carry with him and that supply line that brings him air from the surface. You can also see that he's got an emergency scuba tank just in case. And the visibility under the water can be not great sometimes. So you know that those divers have a really hard job. So we have the divers look for fouling along the side of the ship. And when they find some, they hold up a square for us and they scrape that sample off and they put it into a bag. And then we get to collect that bag. So I also have another video. This is from the diver's perspective. They're collecting a sample for us. And I want you to imagine you doing that yourself. It's a hard job. You can see that the diver has to hold up the square and the bag and the scrapers all at the same time. And it's a really tough job. Here she's going to hold up the bag to read the number to the dive master on the surface. And they were taking some notes and making sure we know where that bag came from and how much sample she was able to collect. She uses the magnet that she's holding herself up against the side of the ship to hold the square for her. She's very clever. There, now she's scraping some of those barnacles and algae off the side of the ship for us and into the bag. Well, she's got it zipped closed and it's going to head up to the surface for us. So here's some pictures of those bags. The one on the right here, it's absolutely full of sea squirts. And the one on the left, that's actually, the sample has started to freeze because it was very cold that day when we were working. So as soon as we can, we pour those bags out into these trays and we look to see if there's any animals still alive and moving around. And so I've got a few cool videos here to show you. So we've got a worm, a jellyfish here. It's hard to see, they're almost translucent. And then a couple different kinds of barnacles, and you can see sticking out their little legs to eat some food. So once we have all those samples, we preserve them in alcohol, and then we keep them in the fridge until we can ship them back here to Burlington. And then what we do is we will carefully sort them and look for all the organisms that are in those samples, and then we'll send them off to experts who can tell us more about them. Now, here's going to be a little bit of a interactive thing, so I'll take my time and you guys can have a look through the microscope and we'll see if we can sort some organisms into jars. So today we've got maybe some barnacles in our sample. So barnacles are little animals that live inside a shell and they stick feathery little legs out to catch some food. We saw a video of those just a few minutes ago. Algae are small, simple plants that like to live in rivers, oceans, lakes, ponds, and even puddles. Mussels are like clams with two hard shells that fold open like a book. And crustaceans are animals like crabs, lobsters, and shrimp that have hard shells on the outside of their bodies, kind of like armor. So what I'm going to have you do is, I keep clicking on the wrong thing. There we go. We'll sort these guys into the right jars. So this one here, think about it. What could it be? If you're thinking it might be a crustacean, you might be right. So we'll put him in that jar and we'll say we've got one crustacean. Now think about this one. How many mussels? Oh, I might have given it away. All right, so this is mussels and we count 5 mussels here. So there's one really big one and then they get smaller and smaller and smaller and smaller. There we go. All right, so what's this one and how many are there? Think about it. If you thought barnacles, you might have thought right. So there's 1, 2, 3, 4, 5, 6, 7 barnacles. So we're going to throw those into our barnacle jar. I won't spoil this one, not this time. These are mussels. There's 4 mussels here. 1, 2, 3, 4. So into they go, that mussel jar. All right, how about these guys? These guys are kind of cute looking with their big eye spots. If you're thinking that they might be crustaceans, you might be right. So they count 1, 2, 3, 4, 5 crustaceans. Into the jar they go. Okay, this one, any ideas? Any ideas? Yeah, it's algae. All right, these guys are weird looking. What could they be? These are crustaceans. There's 3 of them here. 1, 2, 3. Into they go. So we'll take all that data that we've collected and we crunch the numbers and we do some analysis and we extrapolate what we learn from the data to the 8,000 ships that arrive to Canada every year. And we write up these papers and we can share those results with government agencies like Transport Canada. And so you might ask, how does our research help make a difference? So our results help Transport Canada make the rules for the ships, like how often the ships have to be cleaned before they can come to Canada and which anti-fouling paints are required for different parts of the ship. Our results can also guide new technologies in how ships can be cleaned. For example, there's the Jotun hull skater, which is kind of like a fancy Roomba for the outside of the ship, and it travels and drives along the outside of the ship and cleans the ship for while it's underway or it's sitting in port. And we also encourage you and your families to practice the clean, drain, and dry of your fishing boats when you're out going fishing or out for a day on the water to help prevent the spread of aquatic invasive species. All right, thank you very much.
Oh, there we go. Make that camera. There we go. Perfect, Robin. That was great. Great presentation. And as a diver, it looks like a lot of fun getting to work in the water, get underneath those big ships, and then find that life of which it seems like there's a lot to be found on the hulls of those ships, especially when they're traveling great periods of time.
Yeah, for sure. It depends on how long a ship has gone from its last time it was cleaned. There's a lot of factors. So where it came from, how long it was sitting still, a lot of things can go into how dirty or how clean a ship is.
All right. Well, before we get into some Q&A action, I think we'll play a little Kahoot. While you were presenting, I pulled a few questions together, so we'll test our class's new knowledge, whether you're in the camera spot, whether you're tuning in via YouTube. It's very easy to join. So let me share my screen here. You might hear the Kahoot music already. Okay, you need to go to kahoot.it. Today's PIN number is 9352209. So different ways you can join. If you happen to have something like a Chromebook or a tablet at your desk, you could join that way. If not, your teacher could pop this up at the front of the classroom. You could shout out your answers to him or her. If you're joining from home, there's a QR code, whether you've got a phone or a tablet nearby, you can scan that QR code. Finally, if you just can't join us with tech today, that's absolutely no big deal. You can still play along and see how you do. We've got some students or some classrooms coming in here and joining us, which is great. We'll give it another few seconds to get people squared away. But Robin, I think we'll start with just a question to get you warmed up. You know, what led you to a career kind of looking at invasive species, looking at our waters, our oceans?
So I grew up with a cottage on Lake Erie, which is one of the Great Lakes. And I knew from a very young age that I wanted to work with water, and I didn't know what that was going to look like or what that meant, but I knew I needed to do something that would help people and work with water. And I was very fortunate to find a job here with Fisheries and Oceans Canada. And I went through school. I did all my sciences, did biology. And I ended up here working with a great bunch of people.
Yeah, and the Great Lakes, particularly lakes like Erie and Lake Huron, you can definitely see the impact of invasive species. I dive on the wrecks each year.
Yeah.
Some of them are just completely covered, bow to stern, in zebra mussels. There's little invasive gobies on them.
Yeah.
So you see a lot of evidence, and they spread really quickly throughout the system.
Yeah, that's why there's so much focus on trying to keep them out instead of trying to manage them once they're here, because once they're here, there's not a lot we can do. But if we can keep the ships from bringing them in, then we're in a much better place.
Yeah, absolutely. Okay, I think it's slowed down. I think we might have our groups in here with their animal names and ready to go. I have 4 questions for you today, some true and false, some multiple choice. The quicker you put in the right answer, the more points you're going to get. Also, while we're playing Kahoot, we can start putting some questions into the chat sidebar as well, and we'll start working some of those questions in with Robin when we finish up. So here we go. We're going to get counted in, and we'll play some Kahoot. Here we go. First question coming your way. Nice. What's Robin's pet cat's name? Was it Whiskers, Charlie, Roxy, or Speedy? Who remembers that name to get us warmed up? Whiskers, Charlie, Roxy, or Speedy? Got about 9 seconds to lock your answer in. Hopefully everyone's being nice and speedy on their end. And we'll see how we do. All right, there we go. People are awake on a Monday morning. Most went with Charlie. Okay, let's go to our next question. But before that, we'll stop in at the scoreboard. We've got the social chicken holding down that top spot. We will move on to a true or false question. Hull fouling only transports plants. Is that true or is that false? That hull fouling only transports plants. True or false? Lots of time to get an answer in. You've still got 11 seconds to go. And we'll see if we beat the buzzer, if everyone gets their answers in before. Oh, they did it. Good stuff. And that is right. Absolutely false. Plants and animals can cling onto the side of those hulls and be transported to the next destination. The Noble Duck sneaking in to first place. We have another multiple choice coming your way. What impacts can hull fouling have? Does it slow ships down? Does it transport invasive species? Is there more money in fuel? Or is it all of the above? So what impacts can hull fouling have? You still have, I put a little extra time on this one, 16 seconds to go. Does it slow the ships down? Does it transport invasive species? Are there more fuel costs? Or is it all of the above? 6 more. Oh, there we go. We beat the buzzer. Yes, all the above is the best answer. All 3 of those answers work, but the best answer in this case is all of the above. Okay, the helpful urchin making into that top spot. We have 1 more to go, true or false. Once an invasive species arrives in our waters, it's nearly impossible to remove. True or false? Once an invasive species arrives in our waters, it's nearly impossible to remove. Let's see if we beat the buzzer on our final question. 10 seconds to go. All right, that is absolutely true. Yeah, they're so small in those stages too. The larval stages, they reproduce quickly. There's just not a whole lot we can do. Okay, which is why prevention is so important. Third place, we've got the proud giraffe. Second place, we have the helpful urchin. And in first place, holding down that top spot, the Amazon cat. Good stuff. All right, well, thanks for playing along. I'm going to stop that screen share. We'll turn off that music, and we'll focus the rest of our time together on some Q&A action. So like I said, don't be shy. Use that chat sidebar. I see Mr. McGill's class hanging out backstage. I'm going to grab them in a moment to see if they have some questions for us. But we'll start off with one here from the chat. And this first question is just about the quantity. Is there an estimate of maybe how many new species might make it into our Canadian waters each year?
That's a really great question. I think with new treatment systems for ballast water, as well as, these ships want to be clean. It makes it easier for them to travel, and they go faster and it costs less fuel. So we're seeing less and less. So, a few years ago, maybe we see 10 new species a year. This year, maybe we'll see fewer. So getting an exact number is hard, but I think a good number is like, a couple of years ago, we could see up to 10. So let's hope for 10 or less this year.
All right, good stuff. Okay, well, let's check in with Mr. McGill's class and see if they have a couple questions for us. Let me bring them in front and center. Hey, everyone.
Hello.
In your opinion, what is the most destructive introduced species?
Ooh. So I think I can think of maybe two examples. So let's talk about zebra mussels, because they spread really fast. They've been here for quite a while now. I think they arrived to the Great Lakes in the early 90s, and they make a big mess. They're everywhere. They cling on to things like water intakes, and like Joe was saying, like the ships are covered, and they're hard to get rid of. They're here, they're stuck now. So they're pretty bad. But one of the ones that I can think of is that we're trying really hard to keep from arriving in the Great Lakes are invasive carp, and they can be really destructive. And I don't know if you've seen the videos of the carp jumping in the water and smacking people in the face, and if they get here, they could be really destructive and a big problem. So we're working really hard to make sure that they don't spread now any further than they already have.
Yeah. All right. Mr. McGill's crew, do we have another one on deck, or should we come back in a bit?
Yeah, we have one more.
Excellent.
Why do the divers have to put a square on the thing before they scratch at it?
That's a great question. So we use the square, we call it a quadrat. It is 20 centimeters by 20 centimeters. And so that lets the divers and us know that when they're collecting their sample, if they collect exactly 20 centimeters by 20 centimeters every time, we know we are consistent with the samples that we're collecting. And so, like, if you had to draw 20 centimeter square, and every time without a ruler or any help, your square might change sizes depending on how things are going. So we give them that square, and it helps them be consistent. And so that we know that all the critters that I count in the lab came from a 20 by 20 centimeter square. Every time, it's consistent.
All right. Great questions to get us started. We'll check in towards the a little bit later and see if we have any follow-ups. Let's jump back to YouTube now and see what we've got. All right. Miss Gibson's crew is hanging out with us. And the first question here. Okay. So they're wondering, when you're scraping things into the bag, do you seal it? How easy is it to keep everything contained to get the sample back up?
So we use Ziploc bags that have like a pull on the top, because the divers find it easier, because you'll see they have big, thick gloves because it can be cold under that water. So we use those Ziploc bags with a pull. And so we have them scrape things into it. It works really well with big, heavy things like barnacles, but we also have We call them suction samplers, which are like a big syringe. And I don't have a picture of it, but they can use that on lighter, fluffier things like algae, and they just suck it up and then they hold it in that syringe and then they bring that syringe up to us. So most of the time it works really well. Sometimes we have a sample that the bag explodes and then we lose it and they have to send them back down and find a different sample that we can collect. So I'd say like 95% of the time we have good success with the Ziploc bags.
Yeah. So another question from Miss Gibson's class, again, relating to really destructive species in the past, but maybe we can take something from your last answer. You mentioned that now it's a matter of how can we stop them from kind of spreading further into the Great Lakes or maybe up into river systems. So what are some methods that we're using now to try and slow down things like the invasive carps?
So for the invasive carps, they have different techniques. I'm not super familiar with them. So I know that they were using like electrified barriers to try and turn the fish away so they wouldn't swim further upstream. So the fish get a little bit of a unpleasant zap and they go, oh no, I don't want to go that way. And so they turn around. In terms of preventing the spread of things from, say, Lake Erie to Lake Superior, the ships in the Great Lakes are now asked to have treatment systems for their ballast water. So the ships internally, even within Canada, are supposed to be cleaning their ballast and making sure that things don't travel within Canada as well.
Yeah.
And yeah, so we're focused on keeping things out. And I know there's some new species that we're on the watch for. Particularly, there's things like sea squirts and tunicates that we don't want. Green crabs are ones that we don't want to come in and spread any further than they have. So yeah, it's a constant vigilance in making sure that these things don't arrive.
All right. Alexis would like to know about equipment when collecting samples. So what would you say is maybe the most important piece of equipment for doing
Can people be important pieces of equipment? Yeah, so I think for us, we could not do this work without the divers. And so like the divers, they bring all of their special equipment. So all the breathing equipment, all of the flippers and fins and dive, whatever it's called, the suits and things like that. So they come fully prepared to work full day for us. And we bring the science stuff. So we bring the scraping tools and the quadrats, the squares that you saw. And then, so that's the upfront part. So collecting the sample. And then we use our microscopes a lot in the lab. So I think having a good microscope is very important as well.
All right. Okay, more questions coming in. Mr. Lefsby's crew would like to know. Okay, so they're wondering things like the invasive species, some of the ones that come in, like the mussels, are those edible? Eat and cook them?
So I have never tried. I remember I used to work with their little invasive shrimp that have arrived into the Great Lakes, and they're called hemimysis. And I remember working with them, and people think shrimp, they must be tasty, but they're only about centimeter long. And so I would always tell people that, you know, you could try and collect a whole bunch and maybe like put it into a paste and eat it. I have not tried, but I know some invasive species, that's why they're here. So invasive carp were meant as food, and they've spread outside of those holding ponds, and that's why they've come up. Oysters are also an invasive species that people like to eat. So it's often how things get started, and it's they well meant, and then things kind of get out of control and escape, and then they're here and we can't get rid of them.
Yes, we do tend to think that we can control nature, and then
But if somebody wants to eat a zebra mussel, let me know how it tastes. I don't recommend that at all, but
yeah, controlling nature is not easy. And then sometimes we'll bring an invasive species to try and control that other invasive species, and that can lead to even more trouble. So yeah, best to keep them out if we can. So has there been an example of a species that either was fully successfully removed or the numbers, we got them down really, really low?
So I think sea lamprey is a really good example. So sea lamprey are naturally supposed to be on the East Coast, and they've traveled up the man-made canals into the lakes. And they use a lampricide, which is kind of like I don't want to use the word poison, but like a treatment to keep the lamprey at bay. And when it's used consistently and properly in the right doses and in the right places, it can definitely keep them low numbers and under control. But if you stop using it or start using it in the wrong doses or in the wrong places, the lamprey will bounce back. So we haven't eliminated them, but we have we're trying to keep them under control.
All right. We'll keep those questions coming. I do see a couple more in the chat, but I thought I'd check in with Mr. McGill's class again and see if they have a follow-up or two for us before we go back to YouTube.
Go one more.
Awesome.
Do you prefer working on the Atlantic or Pacific coast?
That's a really great question. So we did work on the Vancouver coast the first year we were out there, and it rained all the time, and we were cold, and we were wet, and it was less fun. But I think my heart lives on the East Coast. I quite liked working in Halifax, and even though we didn't get perfect weather every day, I think it's just a nice place to work. And yeah, I recommend, if you get the opportunity to visit both coasts of Canada or even go up to the Arctic, that would be really cool too.
Yeah, absolutely. Well, and that might be something you might have to do as, we're losing that ice. More shipping is going to start traveling through those waters.
Yeah. I think that could be a future avenue for biofouling research for sure. I know our group has done that in the past. They've been up north, and we just haven't been up there in a while. So I think it's time. Let's go.
All right. Let's grab a couple more from YouTube. So let's see. Okay. How do some of the species stick to the boat, stick to the hull?
Oh, good question. So I think barnacles are a really great example because they kind of, when they're in their larval stage, they swim around and they look for a nice spot to settle out. And when they do settle out, they create this almost like concrete sticking solution, and they stick to the side of the ship. And then they grow and grow and grow. And they're perfectly happy hanging out there as long as there's nothing bothering them, like a diver coming along and scraping them off. They're happy to stay there. And then maybe because they're there's a couple nice little niche hot spots where they little crustaceans can come in and they can hide too. And algae can just grow on pretty much anything. So they just find a spot and start to grow. And so we did focus our research on kind of I'll call it the nooks and crannies parts of the ships where they might be a little bit easier for things to hang out and grow. But yeah, we've seen fouling all over those ships.
Yeah. Okay. So the divers going into the water, is there anything that would keep them out of the water, like freezing cold temperatures or things like that?
Good question. So our divers were very brave. They went in the water when it was freezing temperatures above, so 4 or 5 degree water. But they do look at safety. We're very safety first, so we want to make sure that the divers are safe. We want to make sure that the people on the boat are safe. And so if the ship cannot turn off their intake, so the ships use big pumps and they draw water in to run and cool their engines. If the ship can't turn those off, we cannot put divers in the water because it's too dangerous. So the divers won't go in the water if there's reasons like that. The ships can't turn off their pumps, or if there's operations overhead, like they're loading the ship, they won't go under those parts of the ship. They also won't swim on the side of the ship if there's a possibility that they get squished between the ship and the side of the dock.
Yeah.
Or under the ship if there's a possibility the ship's too low, close to the bottom. So yeah, the divers can make their own decisions, and they are their own group, and the dive master makes those calls, but we would never ask the divers to put themselves in any danger.
All right. So, kind of a fun question here. When you're out in the field, is it difficult to make sure that Charlie's taken care of?
Oh, yes. Okay, so that's a fantastic question because like I worry about her all the time. And so I'm very fortunate I have a good support system back home that makes sure that Charlie is fed and if any problems come up, that she gets taken to the vet. And that's exactly what happened on my first trip. My poor kitty had to go to the vet and I wasn't there to be with her. But fortunately, she was fine and everybody took care of her, and I got lots of pictures and videos to make sure that everything was good.
Excellent.
Thanks for worrying about her.
Excellent. Okay, and final question for today: the research you do or the methods that work, does DFO share that with other countries, other organizations?
Yeah, so once we have these results and methods and stuff all nailed down, we'll publish them in scientific papers, and so those will go out that way, and they'll be peer reviewed, and people can look them up that way. But if anybody ever wanted to know our methods, we would share them with them. We doesn't have to go through the peer process or publishing. They just ask us, and we'll share the information with them. So yeah, science community is a great community because we share what we learn, so we don't have to reinvent the wheel every time.
All right. Well, I want to start off before we wrap today with a huge shout out to our classrooms. Thank you so much for the classrooms hanging out with us today. Thanks for the great questions. Thanks for playing Kahoot with us. And Robin, thank you so much. Thanks for sharing the work you're doing with Fisheries and Oceans Canada. It's very important work. And like I said, it's such a great fit with our curriculum. We're always wondering about ecosystems and biodiversity and invasive species. So a real great lesson today.
Thanks so much for having me. And I really enjoyed giving this talk and answering your questions.
All right. Well, a reminder, we still have 2 more events before we wrap March today. So do check them out. We'll be talking about glass sponges, glass sponge reefs at noon, and then robots in space at 1 Eastern with the Canadian Space Agency. So don't miss out on that. And then hopefully we'll see you in lots of events in April. So thanks, everyone. And we're going to sign off for now. See ya.